What's going on, everybody? My name is Kilo Loco, or AKA Kyle Lee. That's my government name. And I am a senior developer advocate at AWS. I am on the Amplify team, and yeah, I'm going to be talking about building apps that scale, in case you couldn't read. So, a little bit about me. I am a self-taught developer. I started back in 2014, started out with iOS. I'm still on iOS. Ew, boo, iPhone, I know. But yeah, I focus on iOS, Android, and Flutter. So there's a lot of different insights that I have from working with a lot of the different platforms, and there's a lot of common problems that I see on each of the different platforms. So regardless of what type of mobile developer you are, you're probably running into a similar problem as somebody from the other side. It's really interesting, actually. And then I'm also a programming tutorial YouTuber. So if you wanted to look up some of the videos, haven't done a whole lot on Android, started some stuff, Jetpack Compose stuff mostly because that's the new hotness, and well, who doesn't like new hotness? So pretty much, like I said, common problems across all the platforms. We're all kind of facing the same problems as mobile developers, and in regards to building out apps that scale. And a lot of people, when I hear about, how do you build an app that scales, a lot of people are looking for like this magic silver bullet, or they think that it's this overly complex topic where you have to, you use this specific dependency injection framework, or you have to use a specific coding paradigm or design pattern or whatever you call it, right? And a lot of the times, it's actually it's not that. It's usually not that. So if you've ever worked on a big team, then there's going to be a lot of different rules in place, and depending on how big the team is, how big the code base is, you're going to see a lot of differences in code bases. It's just going to happen. So it really comes down to, well, how do you scale an app, right? That's what we're here to learn. There's a couple of different answers. There's a couple of different answers, and I think that you'll actually be surprised at some of the things that actually contribute to scaling an app from what I've seen on working on larger code bases, smaller code bases, building out my own code bases, and it's actually a lot of the small things, the details that are responsible for allowing you to scale both your app in terms of code base and the performance as well. So, two of them. The first one is you should have wrote your code base in Python, according to the picture. Or if you didn't do that, well, then you just want to mostly focus on writing a good code base, and that has a lot of different things to do with it. We can talk about code base in terms of allowing it to scale for a team, in terms of writing efficient code, things like that. So I'm going to be giving you 4 different points for each of these. The other one is app performance, making sure that your app is actually performant, that it's going to work the way that it's expected. It's not going to be hanging or things like that. So by show of hands, who has written a function this week? Like 5 people? You guys have really taken vacation, huh? We're in San Francisco, we're gonna go eat pizza or something like that. Okay, so most of you guys got lazy. It's okay, I don't blame you. I haven't written that much code either. Out of those 5 of you that raised your hand, how many of you actually wrote a comment or documentation for your function? Like 3 of you. And then the rest of you guys aren't writing anything. Okay, well, it's actually funny because I actually don't even consider this comment to be documentation or to even be relevant, right? Your function name says do a thing, and then your documentation is it does a thing. Not very helpful. So the first thing that you need to do is start commenting your code, because a lot of the times what happens is half of you haven't written code in a week. You're going to go back to work on Monday, and you're going to be looking at your code base like, well, I wrote this 2 sprints ago, and now I don't know what is going on. That's a major problem, because now not only do you not know what's going on in your code, but also your teammates may not know what's going on in your code, right? And we want to minimize this because for several reasons, right? First, It's not being a good employee. We all want to be good employees, right? Sometimes. But also, sitting there banging your head on trying to figure out what this code actually does, like what is it used for, how can I use it again? It's all important to moving forward, building out the features that you want to build. So what I recommend, in case you haven't seen this, is KDoc and Docker. So essentially, KDoc is essentially the Kotlin version of JavaDoc, in case you've worked with that. And this is providing a way to write your actual functions. And if you want to take a look at some of the information, I have a QR code up here that you can scan, scroll through it real quick, and then you can get a better idea of how essentially you're supposed to be writing your documentation. But it looks a little bit of something like this, right? So not only are you giving some information on what in this case, what the class is doing, but it's also giving more information about like why it was written, the parameters, the properties, all of the different aspects of the actual class. And you can apply this to functions, you can apply this, you could apply this to properties as well. And the reason why you want to do something like this is because, one, whenever you hover over one of your properties or one of the functions, right, and you're looking at it in code where it's being called at, essentially it's going to give you that pop-up describing what it does, right? You don't know what something does, you hover over it, Android Studio gives you the information that was written by somebody that actually did take the time to write a comment, right? So that's the importance of documentation, and like I said, KDoc and Docker, you should definitely take a look into that because it's going to provide you with a format on how to properly write comments. So if we were to take a look back at the function that we had before, do a thing, it should look a little bit closer to this. It's still kind of bare bones, right? But it's a very generic function, do a thing. It does a thing with the value, right? And one additional piece of information that I would like to, recommend starting to add into your comments, especially when you have very coupled code in specific, if you're working in a specific fragment or whatever it is write down the use case as well. Because a lot of the times what you'll do is you'll say, okay, this function does a thing and it takes in a parameter. Yeah, so what? But why was this function actually written, and how does it relate to the overall story of the code, right? So what I would recommend is actually using use cases. Every time that you use this function, include a use case in the documentation so that, one, you know where it's being used, and two, you can understand where you might want to use it next. It is something that wouldn't necessarily scale if you're using it several times, right? In which case you would obviously write something, like if it's a module, right? You wouldn't necessarily write the specific use cases in that case. But if it was within the module and it does something for the rest of the module that isn't exposed, if it's a private type function, then that's when you would use a use case in order to specify, hey, this is what this thing does and this is the use case that we're using it for. So as you can see, when you hover over do a thing at the call site, you actually get some information and then you can actually see the use case. There's also additional annotations that you can add to these comments that will also include like the actual code use cases. You could actually see how you would call or use this function, and you could get as elaborate as you want. It's really unique. Next, don't write clever code. Once again, nobody wants to go back to work looking at their code like this. This is ridiculous, right? We go back, we're looking at it because, hey, we just found out that we can use shorthand. It works everywhere. And you know what? You want to write it all on a single line because, well, I learned it just last week. So we went to DroidCon. They said, look, you can use it there and you can use it there. And Android Studio will actually warn you against this. Like, you're shadowing it. You're doing everything on one line. And it's like, why do it like this, where everything's so just like vague, like you would literally have to stare at this line to see like what is this doing, right? And I don't blame anybody. I see it a lot, actually. I see it a lot in a lot of different code bases because you learn a new skill, you want to use that new skill, but it actually takes away. And I'm not saying that you shouldn't use it, or shorthands or however, but just be very aware of how you're using these shorthands, because once again, this takes away from the scalability of your code base, because if you're spending time trying to learn learn what this code is doing, then you're taking away from the velocity that you can actually be coding whatever it is that you need to build. So what I would actually recommend is, one, use long variable names. There's nothing wrong with long variable names other than that you're banging on your keyboard just a little bit more. But I always opt for the more verbose property names in all of the different languages. Always opt for the verbose property names because, one, it gives you a better idea of what's going on in the code. When you actually read it, yeah, it's not one line. Now it's much longer, a lot more characters. Maybe there's small compile time hits, but in terms of how long it's going to take you in order to figure this out, it's a little bit simpler. All right, organizing folder structure. This is always a really interesting one, and when I came to the Android community, I hated the way that you guys did things. It's bad. Nah. I hated it. But it's a problem, like I said, on all the different platforms. And we all are trying to look for a way that's going to essentially make our project much easier to navigate, know where things are. And when we just start out, folder structure might look like this: long list of all the things. Just stick all the things right there. And that's not helpful. I mean, it's alphabetized, but it's not helpful. So then you end up with all the, and as your app continues to grow, right, this list is only going to get longer. You're going to have so many files. You're going to have to be looking for everything alphabetized and everything like that. What I do see more commonly in the Android community is something a little bit more along the lines of this, right? You have your main application, and then everything else is broken down by like models or UI, util, view model, things like that, right? And this is actually, the first time that I ran into this as being a pain was when I started trying to learn how larger Android apps were built. And I would go on to GitHub, and then I'm trying to find out, okay, I want to learn how to do posts. I want to learn how to make a list. I want to see how it interacts with the view model, navigation, things like that. But then I have to navigate out from the UI screen, go into the utils. Is it in there? No. Is it in the view models? It's harder to find. So what I would propose is actually breaking everything down into feature sets. Now, this is a little bit harder to do because you have to figure out where to draw the line in terms of features, right? You might have a component that does a very specific thing. You could break it out into a package, but hey, at least you can break that out into a package. It could be its own thing, and you would have all the information right there. Now, the great thing about this is that you actually have consistency. You bring somebody new onto the team, you're introducing them to the code base. Guess what? This layout is much better for anybody that's new to the team. It's better for you, less overhead. Every folder structure has the same folders in it, right? Maybe not necessarily everything applies in each of the features, but overall, you're seeing that there's duplicates in terms of like the model, the UI, view model, whatever else needs to be duplicated across each of these features. At least you can go into the specific feature, open up all of those folders, and you can have them all expanded, and then you can navigate around. It's a much easier experience. I do this in every one of my projects, regardless of what platform it's on. So would highly recommend building it out this way. And it also, additionally, if you do start white labeling apps, which essentially means you take one app, you put a different sticker over it, and then you call it a different app, and it does practically the same thing, but it's branded differently because maybe you sold it to a different company, whatever. It works for building out packages like that. So it not only does it mentally help you prepare for packaging up your code, but it also gives you that consistency across each of the features. So would highly recommend that. It would be so much nicer if I could just go onto GitHub, know exactly what feature I'm looking for, and then find all the different information about it. All right, so who in here has wrote a test in the past month? Oh, that's good. Half the audience. It's good, but it's not great. All right. Okay, well, testing your code. And the reason why we test code is, one, because when you start testing your code, you like to talk about it. Everybody seems to like to talk about it as soon as they learn how to test. But also, the other reason is because we don't want to wake up in the middle of the night receiving phone calls like this. I don't know how many of you have had outages on your app, but it's a pain in the butt to get a call because whether you're off work or you're sleeping like this, find out that there's an outage in your app, and it's all because you changed one little thing, you changed a variable, you moved one thing, changed the file, whatever. And everything just starts blowing up. So now you have to wake up and you have to get back to work, and it's not a fun experience. Now, a lot of the time when I'm working with other people, I take a look at their test folders. Looks like that. If you see your test folders look like that, it's not a good sign. And the reason for that is because we have two files. They're both the example files that started out with your project. You didn't write any tests. So let's change that. I can't get into how to write all the different tests. There's just a little bit too much to cover, and that's an entire talk on its own. But what I will tell you is let's start focusing on writing tests. Now, in case you weren't familiar with the two different types of folders that we have here, we have the top one, which says Android tests, and that is for anything that is going to require the life cycle in terms of, like on create, or you're using anything that requires the Android components in order to build or test. You can also put some of your implementation tests where two different classes are interacting with each other, things like that. The second one is where you should actually see a lot more files, a lot more tests. And this is going to be where you're doing your unit tests. Now, unit tests are how you test like a specific thing. If you wanted to test maybe like a repository or a specific class, a helper class that does a thing, right? And the reason why you want to also focus on tests is because tests help enforce some of the best practices when you're coding. So as was mentioned in the talk just previous to this, a lot of the times if you haven't started working with the dependency injection, a lot of the times what you'll see when you're learning about dependency injection is that you have the abstract class, the interface, right? And then you would have an impl class, the implementation, the concrete class. And the reason why you want to do these types of things, or the reason why testing allows for best practices, is because when you're testing, what you're going to find is that you're going to have different dependencies, and you're only supposed to be testing a specific thing. You're supposed to be testing a specific class that does a specific thing, a specific function, gives you a specific output, right? And in order for that to work, what you're going to need to do is you're going to possibly have to inject some type of dependency, and you're going to have to worry about that. So when you start working with things like mocks and fakes, that's when you're going to really be able to see like, oh, the benefit here is that you're not actually injecting a concrete class, because maybe the concrete class that you need to inject is your repository, which is connected to your database. And then next thing you know, if you're working on that concrete class, you are modifying data in your live database, which would be a pretty interesting situation. Lastly, it just makes you feel good. Look at all those green check marks. You get those green check marks for the first time, it gives you like a coder's high. I don't know. I don't know if it's just me. Every time I see the green check marks go off, it makes me feel good. It's like I did something that day. And if you have one of those slow days at work where you just don't feel like doing anything, a lot of the times, tests, you just copy and paste. Makes it look like you did a lot of work and you didn't have to do a lot of work. So JUnit is probably, I think the most popular from what I've seen. I think most people are still using JUnit 4, but JUnit 5 is out. There are some, I believe there are still some limitations on JUnit 5, but QR code there if you want to check it out. Some of the documentation, it's like the gold standard for Android development in case you haven't started using it. All right, so that was like the code base stuff, right? Things that we can do with the code base that will allow it to scale, allow our teams to grow bigger, allow us to write more complete features, things like that. So then what we have is the performance of the app. So the first thing that you should look into is reducing the app start time, because in order for you to need to be able to scale your app, you need to have users. And users, quite simply, are not going to stick around for an app that hangs on the runtime. Now, if I click on your app and I'm sitting there like this, there's a chance that I'm just going to uninstall your app. I get finicky. You should have your app up and running as fast as it can, and it should not exceed 5 seconds from a cold start. So in terms of the different types of startups, there are cold start, which is usually after you simply boot your device, and then you're launching the app for the first time during that boot, right? It could have been a fresh install that also would qualify for a cold start. Then you have what's called a warm start. Now, a warm start's, like as you might be able to tell from the name, very close to a cold start, but essentially the process has initiated, and maybe during the launch of the app, maybe the user like goes to a different app, they switch screens. Then that's something that you would have as a warm start. The app hasn't finished fully going through all the processes, but it has started some of them, and it will launch faster the next time around as opposed to just the cold start. And then lastly is a hot start. This is probably what a majority of the users that you're working with are probably going to do, and it's probably the same way that you might be using your apps right now. You know, you're scrolling through Instagram, you swipe up or you go back and you go to a different app, and then you go back to Instagram or whatever, and then that is going to be your hot start. The app went into the background, all the processes, some of the processes have gone to sleep, but the majority of them have kicked off and they're fine, and all you really have to, all that's really going to change is this on start function is going to be called, and that will trigger specific refreshes in the different apps that, depending on what the app is supposed to do. So, one of the first ways to figure out how fast your app is starting up, and you could do this right now if you have your laptop and you have emulator running, run your app, and what you're going to do is you're going to set logcat to no filters, and you can search for displayed. Displayed will, when you search for displayed, it will spit out a string from the activity manager right here. It's already doing it. You don't have to do anything special. And as you can see at the very end, it'll give you how many seconds and milliseconds it took for your app to launch. So that's the first thing. You start looking into that. How fast is your app launching? Is it less than 5 seconds? If it is, then great. You want to try to lower that because there are some common problems that a lot of apps run into. Then this is where you need to start looking. Are you overriding the application object? A lot of us are. There's nothing wrong with it. You just have to be careful what you're doing, and you want to make sure that you're not doing anything that's unnecessary when you're building that app object. This is the first object that's created, and anything that's extra is going to cause that splash screen or the launch time to essentially hang. Try to minimize that as much as you can. If you don't need to have something done in the application object, in your custom application object, don't do it there. Next are complex tasks in the main activity. So this is where you'll see things like dependency injection graphs are being built, UI is being inflated, stuff like that. When you have really complex UI hierarchies, that's going to cause your app to slow down. Doing a lot of lazy loading, or if you're not doing lazy loading and you're just running all the things, building all the things all at once, it's going to contribute to a slower app start. And then lastly, Splash screens. Splash screens are great. If you are working with the older app, if you haven't started using the splash screen API, you should be using that. It changed back in Android 12, and what you want to do is you want to be using those APIs as opposed to like the not show preview window or whatever it was called, and make sure that you're using the most current APIs when you're building those splash screens, or get rid of the splash screens, because splash screens are cool, but I mean, I don't know about you, but I don't remember splash screens. All right, so next is make user interactions quick. If you're scrolling through an app that has some type of like system, and you tap like, and it takes this long in order for you to see a heart appear on the post, like, what is that? Well, a lot of the times it has to do with waiting until some type of complex or asynchronous process has ran before you're actually just toggling the UI, making updates on the UI. It's a common problem, but you don't want to do this. Overall, what you want to do is you want to update the UI based off of the user interaction, and even if that user interaction were to fail, if you were to like that post and that were to fail, it is better to show the user that this interaction went through, that it's working, and then maybe present some type of error. So as opposed to waiting until the API gets back, because you have to worry about things like, okay, internet connection, are my servers just really overwhelmed right now, and it's peak hours and everything's coming back slow. There's all kinds of reasons why networking requests can take a long time. You don't want to wait for your UI to come back, or you don't want to wait for an API response to come back in order to show the user some type of interaction that they're already expecting. So what you could do is you could essentially update the UI synchronously, essentially. You don't wait for the asynchronous callback to come back. You update it. It may be invalid. Maybe it shows a like, but it didn't necessarily like, but that's still a better experience than waiting for every request to go through and taking forever to come back. Next, storing data locally. So what you want to do, or one thing that is really interesting, is actually, instead of having your UI being completely bound to the internet and only showing what can be displayed on the internet, we want to store data locally, because as soon as you lose internet connection and your phone turns into a brick, we're not having it. I'm done with my phone. If my phone's a brick, if your app is making my phone a brick, then I'm getting rid of it. So the way that this process works is the client sends out an API request. It's already what you're doing right now, right? It hits the API sends back a response. You might be taking that data, displaying it directly on the screen, and giving the user essentially what they're showing, right? What I'm proposing is that, as opposed to taking that data and plopping it on the screen, what you do is you store it locally to a local database. Now, you could do this in several ways. You could do this with Room. You could use SQLite, however you want to do it. But essentially, what you should be doing is you should be taking the data, storing it into a local cache, a local persistent cache, and then what you're doing is querying that local data and displaying it to the user. Now, there's a couple of different benefits to doing it this way. One, no internet, no problem, right? You start saving this data to your local database. Now, whenever the user launches the app, they immediately have data to be displayed onto the screen, right? They're no longer being held back by their internet connection, or your servers are down or whatever. They're still able to scroll through, see whatever was there last. They don't have the latest information, but they still have some information. And depending on how you build out this system, they may be even able to interact with the app, and then when the internet connection comes back, those changes are sent off, if you build it out that way. Now, faster read times. Obviously, you're querying locally much faster than doing any API request, right? So you're going to have a more responsive, faster app. And next, and our last point, which is choosing the right backend resources. So this is going to be one of the biggest ones that's going to contribute to the scalability of your app, and that's going to be essentially how fast are you able to do the thing that your backend is going to be doing, right? So like I said, I work at AWS. You might have seen this. Yeah, they do more stuff than just deliver packages to your door. They build out entire web services. So one of the things about AWS before I started working there was, as a mobile developer, it didn't really feel accessible to me. You go to AWS, you look at the console, and man, are there like a lot of services. Like, wow, like where to start, right? Overwhelming, and it's web services. Amazon Web Services, not mobile services, web service, right? So you hear this, and then it's like, I don't know where to start. Well, the awesome thing is that AWS listens to their customers, and a team was built called AWS Amplify. Now, AWS Amplify is a suite of tools that essentially allows you to take the different AWS services, wrap them in a way that's easier for a front-end or mobile developer to understand and use. Now, the thing that I love about this is that you don't necessarily need to know a whole lot about AWS in order to get this thing working. And if you want to take a look at what is all encompassing in AWS Amplify, because it does quite a bit, and it makes your life a whole lot easier, QR code there to scan it. But let's take a look at it from an Android developer's perspective, right? So there's a couple of different things that you'll see here if you were to go over to the docs site. You're going to see a list of different categories. This is the libraries tab specifically. So when you go over to the docs, you'll see different things. Analytics, API, authentication, data store, geo, prediction, storage, debugging. Now, I'm going to go over 3 of my favorite ones, because these are features that you will find in practically every app. Almost every app is going to have authentication, right? You need to authenticate a user in order for them to use your app, in order for them to do a thing, right? And this is essentially how you capture data about this user, provide them with a username, an avatar, things like that, stuff associated with their profile. And if you take a look at the code, it's actually quite straightforward. You don't have to do a whole lot. You don't have to really know a whole lot about what resources are needed in the back end when you're spinning up those resources. It's all essentially handled for you by the use case that you're looking to solve. So in this case, I'm looking to solve the ability to sign in and sign up users. I use the authentication category. Very simple, very straightforward. Provide a username, password. Bam, it works. Same thing with sign in. Username, password, it works. The next most common feature in an app is file storage. You are going to probably have a user avatar. You're probably going to have, maybe audio files, images, videos, whatever it is. And a lot of us, even if we're not back-end developers, a lot of us have heard of the AWS resource, Amazon S3. Amazon S3 is a bucket system that allows you to store those files. It's very popular, it's very performant and scalable, and it's used by a lot of different companies. So essentially, what you would want to do is you would want to be able to upload some type of file, whether it be an image, video, whatever, and be able to download that, right? And once again, a very simple and straightforward API, amplify.storage.upload file. You provide a file, it goes up to a bucket, it's stored there based off of the different authorization rules that you specify. You can have it accessible to guest users or only authenticated users. And then the last one, which is going to essentially do the thing that I was talking about, which is storing data locally, is data store and API. Now, data store, you can think of it a little bit like Room. It works in a way where it's storing data locally, and it's going to essentially query that data from a local database, right? The and API part is a different category where they work together, and it uses the Amazon resource called AWS AppSync. So AppSync will essentially detect any changes in your local database, and then it will send those changes up to the back end where all the data that's shared across all the different devices are going to be checked, and then it's going to essentially sync that data with Amazon DynamoDB, another popular database system. So, of course, what does something like this cost? Well, with AWS, you have access to a free tier. If you've never made an account, you can go ahead and grab this QR code. It will take you over to the AWS free tier system. You sign up, you get an account. You can use AWS Amplify for a whole year. Check it out. It'll even allow you to see how much you would have spent working with this, so that you can make a better, more well-informed decision to see, okay, I was using this much of my resources, and this is what it would have cost. And usually, it's only a couple of dollars if you're not, Facebook or something like that. Then, yeah, it's essentially really affordable and something that you can get going. Now, what happens if you get stuck? Well, a couple of different options. First, you can reach out to me. I'm here for that. Second is, the docs are pretty good, and we're always looking to make improvements. Everything's actually open source, the documentation, the code base. You can contribute to those, or you can go check them out. And then if you still need help, there's also a Discord server. So the Discord server, full community, you can come in, ask questions, and there will be people from the team that are actually there to help you. I'll be there as well. So with all that said, those are like the 8 different points that I think that are most important in terms of building a scalable app. Once again, my name is Kyle Lee. If you want to reach out to me, you can find me at Kilo_Loco. And thank you for your time.